it didn't tell you it was arithmetic, so you would check to see if there's a common difference. So each time we -4 minus -2. -2 minus 0. 0 minus 2 is -2. So this one has a common difference, so it's arithmetic. So then you'd say, you've got to have this formula memorized for the test. An equation that generates any term in the sequence for this will be a sub 1 plus n minus 1 times by the common difference. So a sub n is equal to a sub 1 is 2 plus n minus 1, our common difference was -2. Now, I didn't notice as I was walking around, I'm not sure, but remember how I've said you're going to need to actually simplify it for the test, as in multiply that actually in. You're going to be doing that today, so you should be practicing that. So then we have this, a sub n is equal to, if we still have this 2, and then now we have -2n, and then we have now plus 2. So our final answer would be, our general formula, a sub n is equal to -2n. Let's write it in standard form, and then isn't it plus 4? There's our general explicit formula. That's the formula that gives us every one of these pieces in the equation. In the sequence. Do you understand that? Okay, now finding the 84th term, you plugged in 84. And what did you get? Did everybody get it? -164. Okay, sweet. Now right here you have to notice there's not a common difference. However, there's a common ratio. If we divide this by this, we get -4. This by this, we get -4. So then you would say, to find any term in the sequence is, for a geometric, once again, you have to have it memorized, a sub 1 times by r raised to the n minus 1. So a sub n is equal to a sub 1 is 3. Our r needs to be in parentheses, -4 raised to the n minus 1. It says find the 12th term, a sub 12. 3 times -4. I saw a lot of you skip right to it. 12 minus 1 is 11, and then you typed it in and got, it's a big number, so just -125. Okay, awesome. Anybody confused? Good job. I was impressed. A lot of you got it right. So let's get going with what we're learning today. A lot of people finished first hour again, so let's reach for that goal. You need a calculator. So everybody have a calculator out ready to go. You might need some blank paper because the work gets a little bit long sometimes. So we have learned arithmetic sequences and then geometric sequences. Today we're doing 11.3, which is an arithmetic, back to arithmetic, and now it's called a series. So you're going to have to know this. What's the difference between a sequence and series? So we have only seen sequences so far. We've just seen a sequence of numbers. They had no meaning. They had a pattern, but a sequence of numbers separated by commas, everybody. That's a sequence, just a sequence of numbers. Today we're going to be dealing with a series, which actually gives these sequences more meaning. What we're doing is, instead of commas, we're not going to have addition signs. We are literally going to be adding them up from one term to the next. So we're going to be finding a sum. Series is sum, sequence is comma. So right, here's an example of an arithmetic sequence. There's just a sequence of numbers listed here. And they have a common difference of 2, notice. This is an arithmetic series. Instead of commas, we have addition signs. We are literally adding up. 2 plus 4 is 6. 6 plus 6 is 12. You get what I'm saying, everybody? We're just adding these up. 4 plus 2 is 6. 6 plus 6 is 12. We're adding these up. Do you get what I'm saying? Okay. Now, once again, it's arithmetic because between each term, there's still a common difference. So it's very similar. The formulas still work. It's just now we're going to actually add those up. So finite versus infinite. This is important to note. For arithmetic, a finite arithmetic series, why is it a series? Because there's plus sign. Finite means you know when to start adding and when to stop adding. That makes it finite. There's a finite number of terms you are summing up. Here's a sub 1, and here's a sub 2, 3, 4. Do you see? We're starting at the first term, and we're summing up to the fourth term here. Everybody see? Finite means we know where to start and end. And you can actually use this formula. So everybody write this formula down. This is the finding the sum formula. So S of n means we're finding the sum of n number of terms. So that S stands for sum. We're summing up. N is the number of terms you are summing up. You are adding up. Sum means addition. So S of n, sum of this many terms is equal to n over 2 times by a sub 1 plus a sub n, where a sub 1 is the first term you're summing up, so like 3, and a sub n is the last term you're summing up, the stopping point. The last term you're summing up. So I'm just going to make a point here. We could obviously add up in our calculator 3 plus 5 plus 7 plus 9, and that would be super easy. I'm going to show you how the formula works, though. So we just said that this was a sub 1, and then this is a sub 4. So wouldn't that mean we're summing up 4 terms, everybody? So this is how you'd write it. You'd say, I'm summing up 4 terms. So then our n is 4, so 4 over 2. And then where did we start? A sub 1 is, where did we start? 3 plus, where did we end? We stopped summing at 9. Now type that into your calculator. 4 divided by 2 times 3 plus 9. What's the sum of those 4 terms? 24. And if you were to do it long or like by hand and go 3 plus 5 plus 7 plus 9, you really would get 24. Does everybody see? Yes. Because this is the formula. We're summing up 4 terms, so 4 over 2. Number of terms we're summing up. Does that make sense? Okay, so you can use that formula to find a finite arithmetic series. Now, here's an infinite arithmetic series. Infinite means you know the start, but we're adding here and we don't know the end. So do you see how we're just going up by 2? So isn't this just going to go on forever? If we start trying to add this up, we're going to be sitting here adding for the rest of our lives because there's no end. It's getting bigger by 2. We don't know when to stop adding. Therefore, you can't find a sum if you don't know when to stop adding. You'd be adding forever. Does that make sense? So an infinite arithmetic series, you would not be able to find the sum. There is no sum. You have to know when to stop adding. Okay, let's put it to use. So everybody just look up here. Find the sum of the arithmetic series. We're going to do it the formula way. So I want you to notice, isn't this a sub 1? A sub 2, 3, 4, isn't this a sub 5? Therefore, we know we're summing up 1 through 5. Does everybody see? We're summing up 1 through 5 terms. We are summing up 5 terms. So the sum of the 5 terms is equal to 5 over 2 times by a sub 1. The first term you're summing up is 3 plus the last term you're summing up is 11. Go, type it into your calculator. 35? Sweet. You could even check it. No. So now look at this one. So we know, so to find the sum. So if we look here, we're like, okay, here's a sub 1, here's a sub 2, here's a sub 3, and then we have plus dot dot dot. We're now clear to 100, and that's where we're stopping at sum a sub n. Now if we figure out that this is a sub 20, we know we're summing up 20 terms. Does everybody see? So this is why last time I had us solve for n, because that's what we need to do right now. We don't know how many terms we're summing up. We don't know where it stopped, at what term. So we're going to have to push pause on finding the sum and figure out what n is first. So this is how we would do it. We'd say, what's the true statement? What equation gives me these numbers? Our explicit formula, a sub n is equal to a sub 1 plus n minus 1 times by d. Plug in what you know. What's our last term? 100 equals a sub 1 is 2 plus our n minus 1. What's our common difference? 2. Now solve for n, and then we know what term that is. So subtract 2. So then that's 98 is equal to n minus 1 times by 2. Divide by 2. So then that's 49 is equal to n minus 1. Therefore, n equals 50. So guys, this is a sub 50. Therefore, we know we're summing up 50 terms. So that's where we stop. After 50 terms, we stop adding. Does everybody see? So now we can go and do our formula. We'd say the sum of 50 terms is 50 over 2. And then what was the first thing we're summing up? 2 plus the last thing. 100. Type it into your calculator. The sum of those 50 terms will add up to be anyone? 2,550. So let's put this into context for you. For example, let's say that your mom isn't very good at math, and she says to you, okay, how am I going to get you to do your chores? And you say, I'll take a $2 allowance if you'll increase it by $2 a day. And I'm only going to, and so you're like asking for this, and she's like, okay, I think that sounds like not a bad plan. And you say, until our vacation. She hasn't really thought about it, but your vacation is 50 days away. So you got $2 on the first day, the next day you get $4, the next day you get $6. So now we're going to start adding these up to figure out how much money in the end you're going to come up with. Your mom is going to owe you, after 50 days, your mom is going to owe you $2,550. It was a good vacation. Yes. Okay, so let's see if you can do this one by yourself. Ready, set, go. You're going to be able to finish your class. Just stick with me. So the correct answer was 1030. Hopefully you all got it. What? Hey, do we need to do one with I want you to just watch one with a negative to see that it doesn't do anything different. You don't have to take notes. I'm going to fly through it like a maniac, so watch. So it says find the sum. So you say, well, here's a sub 1. Here's a sub n. We need to know what term that is. So real quick, we'd say a sub n is equal to a sub 1 plus n minus 1 times by d. Plug in what you know. A sub n is negative 30. A sub 1 is negative 3 plus n minus 1. What's our common difference? Negative 9 minus negative 6. Negative 3. Solve for n. So wouldn't we add 3? Negative 27 is equal to n minus 1 times by negative 3. So divide by negative 3. So that is 9 is equal to n minus 1. Therefore, n equals, this is the 10th term, a sub 10. So now we could say, okay, cool. Now I'm summing up, I know I'm summing up 10 terms since that's the 10th term. So the sum of 10 terms will be 10 over 2 times the starting point, negative 3, plus the ending point, negative 30. So now you would type it into your, now here's the thing, I'm going to ask you a question. Could you ever get an n of a negative? No, right? There's a sub 1, and then n is the nth term. It's not going to be a negative term. So if you get a negative for n, something went wrong. N is the number of terms you're summing up. You can't sum up a negative number of terms. However, could your sum come out to be negative? Yes. Because if you're summing up a bunch of negative numbers, it could come out negative. So that's whatever that sum is. You would type that in and you'd get it. 165? Negative 165. So look, our sums can come out negative, which makes sense. If you're adding up a bunch of negative numbers, it'll probably come out negative. Okay, cool. Do 1 through 7 on the worksheet. Ready, set, go. Hey, now this is a new notation for us that means the same thing that we just learned. You've got to understand where it's coming from. So we're finding sums. Sums means addition. We're finding sums. So you might see them asking you to find the sum with this Greek capital letter called sigma. This literally means find the sum. That's a sum sign. That literally means find the sum, which is what we were doing. We were adding. We were finding the sum. Does everybody see? So it's a new fancy way of writing find the sum. So this is going to be how they write it. So they're going to say find the sum. You should be writing this down. Find the sum. Then in here, this is going to be the explicit formula that generates the sequence. So look right here at this example. This says find the sum of, this is the formula that generates the sequence. This is an explicit formula that generates the sequence. Don't explicit formulas allow us to find any term in a sequence. Okay, so this says find the sum of that explicit formula. So then down here is your lower limit, they call it. So it's just how many terms you're summing up. So if we're summing up 1 through 10 terms, we'd put a 1, and then our upper limit would be 10. 1 through 10 terms. So how many terms are we summing up right here? 1 through 4 terms. So that'd be 4 terms we're summing up. Does everybody see? This is a fancy way of saying write the sum. Now let me show you what it really looks like, okay? So look at this. We have a sum sign, and then we have n plus 2. We're summing up the first through 4th term. So to find a sub 1, you would plug 1 into the explicit formula. Isn't that how that works? What's 1 plus 2? 3. Okay, cool. Let's find a sub 2. We plug 2 in. What's 2 plus 2? 4. And then a sub 3. Let's plug that in. A sub 4. 4 plus 2 is 6. Do you guys see how this is the same thing? But now this sum sign says sum those up. Do you see? Yeah, so we're stopping. We know we're stopping at the 4th term. It's the 4th, yeah, we're stopping at 4 terms. We're going to stop adding. We're summing up the 1st through 4th term. So now look, I could now use this formula that we learned. I could go like this. The sum of 4 terms, so look, 4, right? The sum of 4 terms, 1 through 4, is equal to 4 over 2. And then what's a sub 1? Don't say 1. A sub 1 is the 1st term, which was a 3. You found it by plugging in a 1, right? And then our final term was plugging in that 4, which was 6. So now you could find the sum. Does everybody see? Just a fancy way of writing it. So you said it's 18, right? Okay, now also guess what's cool? You literally can just type that into your calculator and hit enter, and it will give you 18. We're about to get there. We're about to get there. Don't look yet. We're about to get there. So I want you to understand though, there's a reason I'm talking about this. You've got to understand how it works, because I might ask you something. Look right here. Do you see how this is kind of interesting? This says start at the 3rd term and sum up through the 5th term. Do you see how we're not starting at 1? We're skipping over the 1st and 2nd term and starting on the 3rd term. Does that make sense? So let's see here, just so that we can see. What would be our a sub 3? True? A sub 3 would be 3 minus 1 would be 2, comma, 4, plug in a 4. That was a sub 4, plug in a sub 5. 4, and then I shouldn't be putting commas because sum means sum these up. Now look, how many terms are we summing up? 3. Do you see how 3 through 5? There's a difference of how much between 3 and 5? 2. That doesn't account for the 3rd term. So to find how many terms you're summing up with this, you would have to say we're summing up the 3rd, 4th, 5th. You see how that's 3 terms, everybody? So you'd say the sum, if we were going to do it this way, the sum of 3 terms is equal to 3 over 2 times a sub 1, which is 2, because this is the 1st term we're summing up, even though we're starting at 3. Does that make sense? Yeah, so that's where we're starting, and where do we stop? At 4. So that's how you could find the sum. Or you could just type that into your calculator. Okay, so now I'm going to teach you how to type it into your calculator. Yes, now here's the thing. In a minute, we're going to learn how to take something like this and write it in summation notation so that you can then just type it into your calculator. Yeah. But it's actually not any quicker than just using the formula. But at least you could, I don't know, make yourself feel better. Okay, here we go. So let's go to, we're going to do number 16. We're going to type it into our calculator. Now everybody try this. If your calculator is advanced, this will work. If not, I have to teach you a different way. So everybody hit the math key. Everybody hit math key. Then hit 0. If it brings up a sum, does it bring up a sum sign? Then you literally just can go start typing things in. So what you're going to do, if your calculator, does everybody see, raise your hand if yours has a sum sign. Yep, yours doesn't have it. If it doesn't have a sum sign, exactly like this, with blank, 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 you have to do it the good old-fashioned way like I'm going to teach you in a second, which is fine. So if you do have a sum thing that looks like this, look, it's going to say, it's going to be n equals blank, it's going to have a blank, and then you just type it in exactly as you see it, hit enter. You're going to use, instead of an n, you're going to use an x. Okay. Those of you that have that, you're going to go on to problems 14 through 28, okay? The rest of you are going to learn how to do it with me right now. So you're not allowed to talk if you have that function. Yes. That's the equation. Okay, the rest of you, I need you to hit this button with me. Stay with me. So you're going to set it up like this. You're going to hit the second. Everybody hit second that does not have it. Then hit stat. Let me look real quick. Yeah, hit second stat. Then you're going to go over to, scroll over. I'm going to bring up my calculator. How about? Okay, so here's my calculator. Hit second stat. Is everybody with me here? It doesn't have that. Go over to math. Now look, number 5 says find the sum. See, look, sum. So hit 5 and hit enter. Oops, you don't have to hit enter. Then hit, we have to go back in. We have to go back into where we just were. So hit second stat again. Now we went over to math. Now we're going to go over to ops instead. Now look at number 5 again. That says sequence. We're finding the sum of a sequence. So go to 5. Hit enter. Now, some of you have a calculator that's doing this in an advanced way. It has right now. It's breaking this down for you. It's having you type things in. As you can see, how many of you have the word equation, or what is the word? Some of you out there. What do you see when you type that in? It's not anything complicated. It's just your calculator looks different than mine right now. What does your top thing say? No one's looks like that. Yours all looks just like mine. So yours looks just like mine. Does anybody's look different right now? So I can help you know what you're doing. No one's? Okay, cool. So now what you're going to do is you're going to type in the equation. So type in x minus 1. And then you're going to hit a comma. Then you're telling it we're using variable x. Then hit comma. Put your lower limit. We're starting at 1. Comma. Put your upper limit. We're stopping at 6 or 4. This is number 14. Right here. Then close your parentheses, and your calculator will do the same thing everybody else's is doing now. It's 6. The sum of that sequence is 6. So that was 14. So you just have to kind of do it the good old long way. So I would maybe take a picture of this or write it down, because this is what I always forget. So like, let's say you got to the test review, or like next time, whatever. So you hit second stat, we went over to math, we went sum, then we hit second stat, ops, we went down to sequence, and then we put it in this format. So if you need to take a picture, do. So everybody should be doing 14 through 28. If your calculator does it the long way, you only have to do evens on 14 through 28. This part you are going to have to know. So everybody, pull yourself back to me. I want you to notice something. Everybody look at 14 through 22, that is. Do you notice how all the equations are linear, meaning degree 1? That's how we know it's arithmetic, because think about it. It will always come out linear if it's arithmetic, because this is the general explicit formula for arithmetic. A sub 1 plus n minus 1 times by d. Isn't the only thing we don't know is the n, right? Usually, like let's say we had a 5 plus n minus 1 and the common difference was 2. You see how the unknown is a 1, everybody? It's always going to simplify to be linear if it's arithmetic. So if I said to you, is this arithmetic, geometric, or none of the above, you would say it's linear, so it's arithmetic. Does that make sense? Okay, cool. So look, so number 16, you got 183. Well, that's because it was already in summation notation. So let's look at this one up here. If I said to you, find the sum, you could use that formula I gave you, or that first formula, right? Or you could write it in summation notation. And you do need to learn how to do that. So we would say, okay, this is addition. So that means we're going to have the sum, right? True, everybody? That's addition times means sum. Now we're summing up how many terms. We need to know that. N equals 1 through, we need to know how many terms we're summing up. Let's come back to that, because we know this is a sub 1. Here's a sub n, but we don't know what n is, once again. You see how we're stuck again? If this was 10, we would know we're summing up 10 terms, but we don't know. So I'm going to come back to that. So in here needs to be your explicit formula. Well, arithmetic explicit formulas is this, true? So let's plug in what we know. What is a sub 1? 5 plus n minus 1. What's our common difference? 3. And then you would just take and you would simplify the formula. So right now we're finding a sum of 1 through, we don't know still, put a 3 in, 3n minus 3. So then we have a 5 plus 3n minus 3. So what would that become? The explicit formula would become 3n plus 2. And now we've written it out. But now we have to know how many terms we're summing up. Do you see how we do not know what n is? Let's solve it. So let's set up our true statement. A sub n is equal to the explicit formula, true? So a sub 1 plus n minus 1 times by d. Plug in what you know. What is a sub n? 38 is equal to, isn't the explicit formula, we've already simplified it this? Or we could go through and replug it in right here again. So that's this. 3n plus 2. Solve for n. Subtract 2. So that would be 36 equals 3n. Divide by 3. So n equals 12. So we know this is a sub 12. So we're summing up 12 terms. 1 through 12. So now look, now that you put it in summation notation, to find the sum, you could just type it into your calculator. Okay, let's do one more, put it in summation notation, then we're literally done with the lesson and the rest of the time will be yours. If we're writing it, we're going to call this a sub 1, so then we'll always do 1, if we're writing our own. So let's do number 9 together. So let's write this in summation notation. So you'd say, okay, we're finding a sum of n equals 1 through, we don't know right now. We can find our explicit formula. Because it's arithmetic, look, there's a common difference. 4 minus 7, negative 3. 7 minus 10, negative 3. Do we see? So we would say, okay, our explicit formula is a sub 1 plus n minus 1 times d. That's how we find that sequence, true? So plug in what we know. Our a sub 1 is 10 plus n minus 1. Our common difference is negative 3. Answers have to be simplified, so take negative 3 in. So we have 10 minus 3n plus 3. So what would that be? Yeah, and let's write it in standard form. Negative 3n plus 13. So now we can say, okay, we know now we're doing the sum of n equals 1 through, still don't know, but negative 3n plus 13. Now let's figure out the we don't know part. So aren't we ending at a sub n is negative 5? Everybody? So now you would say, well, a sub n is equal to our explicit formula. So let's just do it right here. So negative 5 is equal to negative 3n plus 13. True? Minus 13. So that's negative 18 equals negative 3n. So divide by 3, so n equals 6. So we're summing up 6 terms. And now you could find the sum by typing it into your calculator. Okay. Yes. Good question. It depends on the problem. On these ones, 8 through 13, I'm just having you write it in summation notation because I'm very confident now that I've seen you do 14 through 28. If I did ask you to find the sum, you could then just type it into your calculator. So just go ahead and do 8 through 13. Do right for every single one of those, write it in summation notation. Finish the worksheet. You should be able to go clear through the back.